Hey, this video is going to be designed more for the how, not the why. I mean, I might explain stuff as I go through. You know I babble. But, yeah, let's just do some example problems. These are same wording. I just actually took this straight from your homework. The point, so there's going to be two problems on here. See it? Right? 2 points. The point is on the terminal side of an angle in standard position. And find the exact values of the 6 trig functions of the angle. So, let's get after it. I'm going to move this one over. We'll be there for you a little bit later. And let's jam. So, first thing you should really do is make an XY. Like from here on out, because now you can have like negative shit. Just make a little XY. Doesn't have to be perfect. Just something where you can kind of place it and go, wait a second. All right. We got a positive and a negative. So, a positive X and a negative Y. So that would be, I don't know, like 4, negative 10, something like that. Huh? And then just kind of draw. Ah. Now I told you, this is the how. Make a triangle. Now we always connect to the x-axis. Do not connect to the y-axis. So when we go in, here we go. Zooming in. Oh, there it is. We're just going to drop a little perpendicular. Let's make ourselves a right triangle. Boom. So now what's this length? This length's got to be 4, because that was the x value. Now let's take that negative 10 out of there and be like, bruh, we're going to call that length negative 10. A negative length seems silly, but in trig, that's just kind of how we roll. That's what we do. And there's a good reason for it later, and this, that, and the other. So let's get it. Let's go get it. And what's funny, the angle we're looking at is actually going this way. But I didn't say that. Oops. I didn't say that. You can just ignore that. Now, so we want to go get this side, the C. All we got here is 4 squared plus, negative number. Make sure you get that thing inside of a parenthesis so you don't confuse it for something different. And now we have our 16 plus 100, right? That's not going to turn negative on you. Don't stress, you good. So now we're going to say the C squared is equal to 116. Well, let's hit that thing with a square root on both sides. Now, the hypotenuse is always freaking positive. Always. Just leave that shit positive until we get to something called, polar. Polar's the way down the freaking road. So we're going to keep this shit positive, and we go 116. Now, if we can cut this thing in half twice, it's divisible by 4, and that means we can reduce it down. So just a quick little game with this, where like half of that's going to be, 58? Oh, so we can cut it in half again. So that means 2 times 2 is 4, and what's half of 58? That's 29. Oh, there it is. So C is actually equal to 2 root 29. Cool. Because once we have this, once we know what our C is, go in here, we're like, let's go. 2 root 29. Come on. Go use trig. Now I told you the angle actually comes from this way. But the way we're going to look at it is the angle here. That's not actually the angle. But we think of it as if it is. As if we're coming out of here. So the opposite. And then, I'm getting rid of that 4. I don't like that thing there. That would be our adjacent. And of course, the 2 root 29 would be our hypotenuse. So now you don't even have to stress about where sine and cosine are positive or negative or this. They just follow it. You're going to be like, all right. So sine of our angle is equal to the opposite, negative 10, over, gosh darn it, I'm struggling, negative 10 over that 2 root 29. I have to clean it. There's an even number over an even number. That's your teacher's pet peeve. He will mark you down for it. He's just an asshole about it. Like, really, this is my pet peeve. Leaving even numbers over even numbers drives me absolutely freaking insane. Because it's laziness. It doesn't really have anything else to do with that. We all know what an even number is, right? You know what an even number is. Do you know what half of something is? So if you have an even over an even, you just cut both numbers in half. What's half of 10? 5. What's half of 2? 1. So that's the game. No evens over evens. No evens over even. So if you ever see something written back to you on an assignment that says even over even, that's why. You didn't reduce it down. All right, now let's go get our cosine, which is going to be 4 over 2 root 29, and we're going to do the same thing. We're going to cut those two things in half. We're going to get the cosine of theta is equal to 2 over root 29. Well, this is sweet. We're good to go. We got there's sine, there's cosine, and now with some speed. Oh, that. And then we're going to go get tangent. But I'm going to cheat. I'm not even going to look at the triangle. I'm just going to look at this. -5 over +2. It's already reduced down. It's beautiful. It's absolutely beautiful. So there's sine, cosine, and tangent. Now let's go get the rest. Cosecant of theta. Since sine is negative, so is cosecant. So when we flip it over, it's still negative. Secant. Just flip it over. Since cosine is positive, secant's going to be positive. The root 29 goes up top, 2 goes down below. And then cotangent of theta, same thing. Since tangent's negative in the fourth quadrant, and it's got -5/2, you flip it over for cotangent. And cotangent's also negative. That's why when we say ASTC, we're just talking about sine, cosine, and tangent. So there's your 6 answers. Now let's go to the next. Now this one is much more of how's your arithmetic? How's your algebra? How we feeling on this shit? We got -2.5, comma 3 root 2. I'm immediately calling this -5/2 because 2.5 is great to speak. It's terrible for math. I'm a math teacher, so unless you're dealing with a word problem, don't give me mixed numbers, please. Please don't give me mixed numbers. I'm a math teacher. I can speak the other way. But if it's a word problem, because you'd sound like an ass saying, like, how long did it take you? 5/2 of a second. You're like, what? 2.5 seconds. You're like, oh, why are you speaking so strange? Yeah, that's my game. All right. Blah, blah, blah. I'm just going to go in and go, look, we got a -x and a +y, which means we're somewhere over here. I don't even care what the ratio is. Not to scale. I'm going to do this, and then I'm just going to drop a perpendicular down. Since this point is at -5/2, that means that right here is -5/2. Or that the length here, it's easier just to call it -5/2. And then the height, the y value typically goes over here, right? Your 3 root 2, as this takes off. But we could say that the length of this is 3 root 2, and we've now made ourselves a right triangle. So it seems to be the same sort of game, that we just need to go find our C, and once we found C, we're off and running. Only issue is, it's a pain in the ass because of the numbers. So we have 3 root 2 squared plus -5/2 squared is equal to C squared. So let's clean this thing up. So this kind of distributes in. That's how you run on things. So 3 times 3 is 9. Root 2 times root 2 is equal to 2. The negative, when you square it, is going to become positive, and we get 25 over 4 is equal to that C squared. So now we have 18 plus 25 over 4. 72. There it is. So 4 and 4, top and bottom. Right, that's how we deal with fractions. So we end up with 72 plus 25 all over 4 is equal to our C squared. And was that 97 over 4 is equal to C squared. Okay, well, let's hit it with the square root. Remember, when we're dealing with square roots on the hypotenuse, they're always going to be positive. So C is always going to be positive. So when we hit this, root and root, no stress. I don't know why I made an arrow that way. Let's just go down. We're going to say that C is equal to the square root of 97 over, what's the square root of 4? Anybody know that one? 2. And that thing's all nice and cleaned up. Not an answer, but now we can go get everything. Now, once you have the 3 parts of a triangle, the 3 sides, sine, cosine, and tangent, no issue. All right. Sine of theta is going to be equal to 3 root 2 over our C. So 3 root 2 over our root 97 over 2. We got to clean that shit up. We got to flip this fraction up and say that sine of theta is equal to 3 root 2 times 2 over root 97. Therefore, sine of theta is equal to 6 root 2 over root 97. I'm not rationalizing that shit. I'll bet you that simplifies down pretty nicely. Well, I don't know about nicely, but it'll simplify down. Next, let's go to cosine of theta. Cosine of theta is going to be our adjacent negative 5 over 2 over our c, root 97 over 2. Oh, hallelujah. The 2's on the bottom just disappear. Everybody's happy. Negative 5 over root 97. I disagree. Actually, I don't think sine would have reduced down much at all. Now that I see this and they have the same denominator, don't they both have the same denominator? So what game are we going to play? We're going to play the game where don't look at the triangle anymore. Don't look at that triangle anymore. We don't need it. Because we want to get this thing beaten into our head to where we have it just on lock. There's only sine and cosine. Everything else is just made up of it. Once you have sine and cosine, you have everything. Screw your triangle. Screw looking at OA and all that sort of stuff. You got it. So we're going to take the numerator of sine, 6 root 2, and make it our numerator. And then we're going to take cosine's numerator, negative 5. We'll make that the denominator. Because tangent is sine over cosine. And now we get the other 3 for free. So cosecant of theta is going to be root 97 over 6 root 2. Secant of theta is going to be root 97, negative over 5. And it doesn't matter where you put that negative. It can be up top, up front, down below. Makes no difference. And then we got negative 5 over 6 root 2. And there is the rest of our solutions. Cool. Be good at this game. Maybe not right this second, but get good with this game. You're going to have to play it the whole freaking semester. So, all right. There.